Today, we will be discussing mass wasting mechanisms. And understanding the mechanisms behind mass wasting events is critical to reducing their effects on the areas that are prone to these powerful events. So, there are several types of mass wasting events, and their mechanisms are dependent upon the material involved and the rate by which this event occurs. Now, there will be three mechanisms to be discussed here. There are the fall mechanism, the slide mechanism, and the flow mechanism. Now, we will examine these in further detail, but generally speaking, the fall mechanism is the fastest mechanism present in mass wasting events, and it occurs when earth materials fall independently of one another, and they free fall down to the lowest point of elevation. So the slide mechanism, which is the second mechanism, and it is nearly as fast as the fall, this can be subdivided into two different categories, the rock slide and the slump. And in these mechanisms, the earth materials tend to move as one large body. And the last mechanism is the slowest mechanism, but should not be ignored just because of that. It is the flow mechanism, where these materials tend to move more like fluids, and they have various subdivisions present. Now, before we actually discuss in detail how these mechanisms work, it's important to understand what a mass wasting event and where they are more likely to occur. So mass wasting is simply described as the downward movement of earth materials due to the force of gravity. Now, in order for this movement to occur, there must be a change in elevation. And this elevation change must be significant enough to generate a slope to allow for these materials to roll down or fall down or creep down or whatever the case may be. Now, the more intense mass wasting events are often associated with areas that have massive changes in elevation, such as young mountain ranges. Now, a lot of the areas affected by weathering and erosion activities, such as frost wedging or heavy rain or high winds, are very susceptible to mass wasting events. Now, there are lots of different types of terrain on this planet, and each terrain has a different mass wasting mechanism that it encounters. Now, the first mechanism to be discussed here is the fastest mechanism associated with mass wasting events. This is the fall. Now, during a fall, earth materials, typically bedrock, become detached from their unstable slope and tend to free fall down to the lowest point of elevation. Now, this can be very, very destructive. The impact of these materials hitting the ground at over 200 miles an hour is intense in and of itself, but most of the destruction is actually caused by the air blast that is generated. Now, this air blast is generated from the displacement of air from underneath the fragment as it hits the ground. Because if there's a fragment traveling at 200 miles an hour falling down, there's a lot of air underneath of it. So once it finally hits the ground, that air has to disperse very quickly, causing a massive air blast, which is strong enough to flatten trees and homes and can actually even trigger other mass wasting events in the nearby area. So the rockfall mechanism, while it can occur in seconds, can have lasting impacts. It can be extraordinarily destructive, as you can see by this flattened truck to the right. Now, rockfall events occur all over the globe, and oftentimes they aren't really noticed because they happen in very uninhabited areas, but people are expanding and living everywhere, so now we're getting more and more cases of homes being affected by these mass wasting mechanisms. So, ironically, in Rockville, Utah, there was a huge rockfall event. And during this event, a 450-ton rock fragment broke free from this cliff that was overlooking a lot of homes and tumbled down the cliff following this path that can be observed here to the right, and collided with a large boulder that was placed there from a previous rock falling event. And thankfully that big boulder was there because it broke this massive fragment up into smaller fragments. Now, a 20-ton fragment is still a huge fragment, but it's not as massive as a 450-ton fragment. Now, this 20-ton fragment that I'm speaking of, after it broke free from the larger mass, barreled through an occupied home and flattened 2 vehicles in its path. Thankfully, no one was injured in this particular event, but there have been numerous fatal rock falling incidents throughout history, and they're not to be taken lightly. Now, the next mass wasting mechanism of interest here is the slide. Now, this slide differs from falls in a very critical way. In a fall, the earth materials fall independently from each other, but in a slide, all the earth materials associated with the mechanism tend to move as one uniform, continuous body. And these slide mechanisms can be divided into 2 subdivisions, and they are known as rock slides and slumps. Now, during a rock slide, there are layers of rock parallel to the slope surface, and these rock layers fracture and slide down the slope at tremendous speeds. Now, occasionally, these fragments can actually ride upon compressed air beneath them, which greatly diminishes the friction that they experience, allowing them to pick up much more speed and be much more destructive and fan out over a larger area than just an ordinary rock slide. Now, in addition to slides, there are slumps. And slumps, on the other hand, arise when the surface upon which the earth material is moving is curved. Now, it can be very detrimental to the areas afflicted because typically they are done by these slumps occur in man-made areas. So there's lots of roads or houses or whatever that are present during these types of mass wasting mechanisms. Now, what initiates these mechanisms is typically rain that oversaturates and increases the weight of the unconsolidated material involved, and this leads to slippage and lack of support by the base of the slope. Now, when the materials at the top of the slope can no longer be supported by the base, they slide down this curvature, and as they slide, they have a rotational property to them to where they rotate and roll as they are falling down the slope. And this creates a whole lot of interesting formations of the material involved. Oftentimes, it can be easy to know that a slump has occurred by looking at objects such as trees or these power lines present in the figure to the right. They are tilted by the slump event that has occurred. And these slump events leave massive upturned areas with huge concave portions of the landscape. And as you'll see in the next slide, they can be extraordinarily detrimental to society, not only in the loss of lives, but in the monetary loss of rock slides and slumps have claimed many lives and have cost billions of dollars in damage repair throughout the settling of our rugged country. Now, when we were settling the west coast of the United States in California, we managed to build a massive highway that stretched all across the western coast. It's called the Pacific Highway 1. And many people love driving down this coastline and looking out to the Pacific Ocean and seeing how beautiful everything is. But just last year, a massive slide event occurred that was triggered by a heavy rainfall, knocked out a massive portion of this highway. Now, luckily, no lives were taken in this event, but it did cost, according to the CEO of Visit California, around $550 million in tourist revenue. And that's just tourist revenue alone. Who knows how much this is going to take to repair, because it's been a year since the event has occurred, and this massive road is still out of service. People have to take multiple hour-long detours to be able to get to where they need to go. So many of the lives of the local people in the area have been dramatically affected by this event that lasted merely seconds. Now, here we will discuss the final mechanism of interest, the flow. Now, the flow mechanism has 5 subdivisions, as can be seen here. There are mud flows, debris flows, earth flows, solid fluxion, and creeps. Now, flows behave differently than both falls and slides because the earth material involved behaves like a fluid. So the mass wasting mechanism occurs often as a result of a buildup of fluids generated from a previous mass wasting event that is a slide. Now, the subdivision of flow that is present is often related to the material and the speed at which it occurs. And the first division of flows to be discussed is the mud flow. Now, mud flows consist of water-saturated materials that are very fine, granulated materials like silt, and they flow much more rapidly than any of the other types of flow mechanisms that we can see here. They're typically generated through periods of dryness followed by heavy rainfall, which causes things to slip and slide down a slight slope. Now, the next type of flow to discuss is the debris flow, which consists of soil, mud, and coarse rock fragments, and they're very common in areas subject to wildfires. And these debris flows can be very dangerous as they can reach speeds of 330 feet per hour, which may not seem like a lot, but it can definitely have a huge impact on the area involved. Now, earth flows happen a lot slower and tend to occur on grassy hills and banks when thawing events or heavy rainfall occur. So these materials that are involved typically consist of clay-rich soils and weathered rock that is typically finely grained. And earth flows are often typically difficult to spot unless they evolve into a mud flow with increased rain and increased factors that will likely transform it into a mud flow. Now, the next flow to be discussed is the solid fluxion. Now, these are very common in areas of permafrost. So basically what happens in solid fluxion is a thin layer of the permafrost will thaw, creating a slippery active layer, which causes all of the layers beneath it to lose their traction, and they can gradually slide down the slope. These events typically tend to be no faster than a few centimeters per year. Now, the last mechanism to be discussed is the creep flow mechanism. Now, this is the slowest of the mass wasting events and is caused by wet-dry cycles or freeze-thaw cycles. And these cycles occur over very long periods of time. And creeps tend to tilt the surfaces that they are affecting forward rather than backward like slumps do. So oftentimes the only way to tell if creeping is occurring is to look at the orientations of trees and objects in the area to see if any forward tilting has occurred. Now, these creeps can prove to be very dangerous because their effects tend to creep up on the people until it's too late to fix the issue that has arisen. So many times it's too late to deal with the problem at hand. You have a house that has been involved in creeping, and you don't necessarily want to leave so fast, but if you don't leave, then structural damage will surely ensue. Now, to wrap everything up here, we need to figure out how can we adapt to this problem. And the only really real way to adapt is to just study and learn about these mechanisms, understand what factors contribute to them, and make this better decisions about where you build your property and where you live to coincide with the natural events that are going to take occur. There are many factors that contribute to these mass wasting events, and they occur over very long periods of time, but the actual events themselves only take seconds, and these seconds can end up having permanent effects on people's lives. Now, mass wasting is ever present, and oftentimes seems that there's no way we can avoid these events from taking place. but some structures have been built without any knowledge to know like what was going to happen in this area. But in recent years, and after studying these mechanisms, people have thought more critically about where they're going to build their buildings and what they're going to do and how they build their buildings. And using this hindsight, by studying these events of the past and what contributed to these massive mass wasting events, we can make better decisions and strategies to deal with these ever-present, inescapable natural processes.